In this video we're going to learn about simplifying ratios, which is very similar to cancelling down fractions. So let's first look at part A, 7 to 21. Now what we've got to do is try to find a common factor, a number that goes into 7 that also goes into 21. Now if you know your 7 times tables, you will know that 7 goes into both of these numbers. So let's do this. We'll divide both sides by 7, which is okay so long as you do it to both sides. Similar to when you're cancelling down fractions. Whatever you do to the top, you do to the bottom. In this case, whatever you do to the left-hand side, you also have to do to the right-hand side. So 7 divided by 7 is 1. 21 divided by 7 is 3. So our cancelled down ratio is 1 to 3. Let's have a look at part B and do the same thing. 450 to 200. The first thing and the most obvious thing I can do, if I notice that there's a 0 on both numbers, I can just cancel those out. That's like dividing by 10. So now what I have is 45 to 20. Smaller numbers, much easier to see. The trick with this one is as soon as you see a number that ends with a 0 or ends with a 5, you know that 5 goes into it. So let's start by dividing both sides by 5, and that might be all we need to do. Once we have a look at what numbers we're left with, 45 divided by 5 is 9. 20 divided by 5 is 4. 9 to 4. There's no number that goes into 4 that also goes into 9, so we can't cancel that any further. Let's have a look at these ones over on the right hand side that involve fractions. Now they look a bit harder, but we're just going to remember the same process as we have just done, and hopefully it won't be too much harder. The first thing I'm going to get you to do though, this one has got a denominator of 5, this one's got a denominator of 2. If we express these with a common denominator, it's going to be easier to compare. So let's have a look. 5 and 2, the common denominator for those two would be 10. So let's write both of those as a fraction over 10. Remembering what you've done in year 7, and you would have done it in primary school, the 5 I've multiplied by 2 to make it 10, so I do the same to the top. 2 times 3 becomes 6 over 10. The right-hand fraction, I've multiplied 2 by 5 to get the 10. Do it to the top. 5 times 1 is 5. Now I've got 6 over 10, comparing that with 5 over 10. I've still got a fraction that still looks a bit nasty. What I'm going to do now to get rid of that fraction is I'm going to multiply both sides of my ratio by that denominator. Multiply both sides by the 10, and let's have a look and see what happens. I'll just do a quick little bit of working over here. If I do 6 over 10 and I multiply that by 10 over 1, my 10's cancel, and I've got 6 over 1, which gives me 6. So by multiplying that fraction by the denominator, I end up with a 6 on the left-hand side, and similar working for this one as over here, I'm going to end up with a 5 there. 6 is to 5, and I can't go any further. 5's a prime number, so there's nothing that can cancel down. Let's have a look at part B and do exactly the same thing. The only extra is going to be that I've got mixed numbers here, so I need to convert those into improper fractions first. So again, thinking back to what you've done in year 7 with fractions, to make this into an improper, I do 2 times 3 is 6 plus 1, I have 7 on 3. 1 1/4, 1 times 4 is 4, plus 1 is 5 over 4. Now we're in the same situation as we had in part A up here. We're going to get a common denominator. 3 times 4 is 12, so I'm going to write them both as 12. I've multiplied 3 times 4 to get 12, so I do the same for the top. 7 fours are 28. For my right-hand fraction, I've multiplied 4 by 3 to get 12. Do the same up here. 5 times 3 is 15. Then, like I did up here, I multiplied through by that denominator. In this case, I've got a 12, so I'm going to multiply both sides through by 12. I'll just change the colour there. This one here times 12. This one here times 12. So I'm going to end up with 28 to 15. Now these are fairly high numbers, and you're right to be thinking, can I cancel this down at all? But if you think about 3 and 15, 15, the only factors of 15 are 5 and 3, and not 5 or 3 don't go into 28, so that's all you can do. Let's continue on and look at worded questions. These always look like they're going to be a bit harder, but they're not. The only thing you need to remember when you're dealing with worded questions and when you've got units is always convert all values to the same units before you start. So what I mean by that, in this one I've got millimetres, in this one I've got centimetres. You can't compare them because they're in different units. So for part A, my 2 centimetres, I'm going to write that as 20 millimetres because for every 1 centimetre I've got 10. So 2 centimetres has got 20 millimetres. Now I've got 4 millimetres, which I need to compare to 20 millimetres. Now I'm just going to cancel it down just like I did on the other page. 4 goes into 20, so that's our common factor. I'm going to divide both sides by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. As simple as that. Let's do part B. I've got minutes and I've got hours. I need to convert everything to the same units. So 2 hours is 2 lots of 60 minutes, which is 120 minutes. Now I've got minutes here and minutes there. I can compare them. So 25 minutes to 120 minutes. As I said on the previous slide, if any numbers end in a 5 or 0, then I know 5 goes into them. So I'm going to divide both sides by 5. 25 divided by 5. That's one of the 5 times tables, so that goes in 5 times. 120 divided by 5. You can use a calculator for this, or you can do it in your head. If I go 5 into 12, that goes in 2 times, and I've got 2 remainder. 5 into 20 goes 4. So 5 to 24 is our simplified ratio. Good luck.